Hey, I had a question asked about, this is from chapter 20, so this was page 472 in your textbook. This was one of our homework problems, and there were some people who didn't know how to do this, so I wanted to spend some time talking about it because this actually is a great review of both confidence interval and hypothesis test. Now, at some point, you're going to see magic or writing magically occur because I'm going to pause it and do a bunch of writing so it doesn't prolong this. But I wanted you to kind of see how my brain works when I read a problem, so and what I write down. So a study of the effects of acid rain on trees in the Hopkins forest shows that out of 100 trees sampled. So when I read something like this, I write n equals 100 because I know right away that's what I'm dealing with. 25 of them exhibited some sort of damage from acid rain. Now I know that this is dealing with a sample, 25 out of 100, so I'm going to call that p hat. 25 out of 100, or you can write that as 0.25. So that's my p hat. This rate seemed to be higher than the 15% quoted. So this is the kind of the status quo. This is what we believed to be true was the average proportion of damaged trees in the Northeast. So when I get ready to do a significance test, this is going to be my p-naught value, is 0.15. So I'm dealing with that for my hypothesized value. Does this sample suggest that trees in the Hopkins forest are more susceptible than the rest of the region? Comment and write up your own conclusions based on an appropriate confidence interval as well as a hypothesis test. So this is unique in that they're asking us to do both. So I'm going to include any assumptions you made about the data, so that's telling us we need to check the conditions. So I'm going to start with some conditions. Now there are some conditions that we use for both confidence intervals and significance tests. I'm going to start with those. So the idea of random. Now we are not told anything about a random sample. So we're going to make an assumption here, and we are going to assume that 100, let's say the 100 trees are representative of the population. So we need to be able to make that assumption. Then we need another condition, the idea of independence. This kind of goes along this same idea. And whether or not that's true, we're assuming that the trees are independent of each other. That could be an issue because if they're all from the same region and if there was not a random sample, they do say that 100 trees were sampled, so we don't know that part of it. So the independence idea, could be a little sticky. So we're going, but if they're representative, this kind of ties in. If they're representative, so it's kind of the same, kind of go together. But we could have an issue there, and so that might be something that I would comment on. Then we need to know that our sample size is large enough. So remember what you have to do on that. Now for a confidence interval, we're looking at n times p hat greater than or equal to 10. And in our situation, we had 25 of them. N times p hat is 25, which is greater than 10. And n times 1 minus p hat is 75, also greater than 10. And then for that's large enough but not too large, we're going to say that 100 is less than 10% of all trees in Hopkins forest. Okay, now the only thing that's different for a significance test is this one right here. So for a test of significance, we would be testing n times p naught, which is 15, because 15%, which is still greater than 10, and n times 1 minus p naught would be 85, also greater than 10. So that's the only condition that's different is what do you use for that p. you use p hat if you're dealing with a confidence interval. You use p naught if you're dealing with a significance test, because that's what we are assuming to be true. Okay, so here's, it all magically appeared here. Don't forget to name your procedure or your test, in this case the interval, a 1 proportion z interval. That is extremely important. Then I chose to do a 95% confidence interval. You were not told that, so you could have done a 90. You weren't given that level, unless I read it wrong. Nope, don't see that level. Then you do 1 proportion z interval on your calculator. Remember, if you've named your test, you do not have to use the formula. Then I would list out what that was, and my interpretation that is so critically important. I am 95% confident that the true proportion of trees only need one of trees in Hopkins Forest that are damaged by acid rain is between 0.1651 and 0.3349. Then that would be my conclusion. And that would be fine as your conclusion. Sometimes you are asked what's meant by 95% confidence. This is what that means. In repeated sampling of 100 trees, so repeated sampling of that particular sample size, 95% of the intervals created will capture the true proportion of trees damaged by acid rain. That idea that every time you draw a new sample, you get a new interval. 95% of the intervals you create will capture the true proportion of trees damaged by acid rain. Okay, so here's the significance test. Our null hypotheses, remember it's always about p in this case. That's our parameter, the proportion. So it's always about the population, not about the sample. So never use a p hat when you are talking about your significance test. So my null hypothesis p equals 0.15. In words, that means the proportion of trees in Hopkins Forest damaged by acid rain is the same as the average in the Northeast. My alternative would be to say that p is greater than 0.15, which in words, the trees in Hopkins Forest are more susceptible than the rest of the region. Now, I want you to look back at the wording of the problem. Look at the question. Does the sample suggest that trees in the Hopkins Forest are more susceptible than the rest of the region? I used the same words. When I go through and I set up my significance test, I look back, and whatever the question is, typically your question that you're trying to show is in your alternative hypotheses. So borrow the words from the problem. Then you're guaranteed to have them right. So this is what you're trying to show to be true. It's a greater than test because I'm trying to show that the trees are more susceptible than the rest of the region. Remember, my population I'm talking about are all the trees in Hopkins Forest. So you want to make sure that you're clear on that. My conditions we met in the previous slide. So I'm going to do a 1 proportion z-test. Do not forget to name your test. Here are the screen captures. Make sure you have the right test. Make sure you are able to produce what I have here. Write down your z-score, write down your p-value. Remember, the p that's shown there is your p-value. So I have 0.0026. Here is my conclusion. If the proportion of damaged trees in Hopkins Forest is the same as the rest of the region, those are in words saying if the null hypothesis is true, but put the context to it. Then the probability of getting results as extreme or more than ours is only 0.0026. So that's my p-value. So a p-value is a conditional probability. If the null hypothesis is true, this is the probability I would get results like mine or more extreme. So then I have to talk about what does that mean, a 0.0026. That's a low probability, and don't assume that people are going to know that. You have to say it. That low probability gives us evidence to claim that the null hypothesis or the alternative hypothesis is true, but put it in context. That the trees in Hopkins Forest are more susceptible than the rest of the region. Look what I said. Exactly. The trees in Hopkins Forest are more susceptible than the rest of the region. I'm saying the alternative is true, but I'm using the words. That's why taking time to think about these words is worth it, because you're going to use those when you make your conclusion. Now, I want to point something out to you. We rejected the null hypotheses. I want you to look back here and look at our confidence interval. Notice that 0.15 is not captured in the confidence interval. Now, because I did a 95% confidence interval, let me draw a picture here. So because this is an important idea here, so I want to make sure you understand that. When you have a 95% confidence interval, we're dealing with a normal model. Sorry, that's not a very good one. But if this is 0.95 then this is 0.025. So because I did a one-sided test, this would be equivalent. So this is a confidence interval. But a one-sided test would only be looking at this. I did a right-tailed test. So notice that my p-value is less than 0.025. So my p-value was 0.0026, which was less than 0.025. If I am going to compare this to a confidence interval is always two-sided, and a significance test can be one-sided or two-sided. So you do have that issue where they don't always match up. As far as the conclusions, making sure they match. But in this case, they do. Notice that my 0.15 is not in the confidence interval. So I would have evidence from my confidence interval to state that the trees in Hopkins Forest are more susceptible to acid rain damage than the rest of the region because the entire confidence interval is above 15%. So you can use a confidence interval in many of the same cases you would use a significance test. This is a great problem because it asks you to do both things. This kind of covers everything from chapters 19 and 20 all in one problem. So it was worth taking the time to go through, and I hope you watched it.